Page 32, estimate products and quotients. What are products? What are quotients? What are products? What are quotients? Yeah. Very good. So we're going to estimate products and quotients today. And sometimes there are going to be different ways in which we will be doing some rounding. Now, I will show you the different ways. We will talk about the different ways in which we estimate. And sometimes some methods will work better than others, depending on the situation. The first one that we're very familiar with is the method of rounding. Okay? It's the method of rounding. For example, if we were to have 46 times 88, and I wanted you to estimate that particular problem by rounding, we would first of all take a look at what it is that we have. Both of these numbers extend to your tens place. So it'd probably be a good idea for us to round both of those to the nearest 10. 46 would round to what value? 88 would round to 90. Okay? Now from here, once we have 50 times 90, we can use mental math to help us do a majority of the work or all of the work pretty much in our head. I'm going to focus on the 5 in the tens place on the 50 and the 9 in the tens place on the 90. 9 times 5 is 45. And then at the end, I'm going to tack on how many extra zeros? So my estimate using rounding would be 4,500. Okay, majority of the work, again, was done in our heads. If in the last example, both of our numbers extended to the tens place, this example, both of our numbers extend to the hundreds place. So again, it's going to be in our best interest to round each of these to the nearest hundred. 689 would round to what, Josiah? 700. 943 rounds to 900. The 7 in 700 times the 9 in 900 is 63. And how many extra zeros are we going to tack on to the end of the 63? 4. And then we'll add commas accordingly. Okay. In this example, they both don't extend out to the same place value. In which case, I will round them to their highest place value. See, it does me no good to round 34 to the nearest 100. Why? Why would it do no good to round that to the nearest 100? CJ, what would it round to? Right. Round to 0. So regardless of what, if I were to say, okay, here's where my number in the hundreds place would be, Is that 3 large enough to get anything in the hundreds place? No. So we round to 0, my estimate would be 0. Is that an accurate estimate for 34 times 319? Not at all. So what I'll do is, since the 34 extends to the tens place, I'll round it to the nearest 10, which is 30. Over here, I'll round that to the nearest 100, and we should get 300. Does it get smaller? We don't go down to 200 if this is less than a 5. We just stay the same. We stay at 3. So now 3 times 3, 9 with how many extra zeros? 1, 2, 3. And then we'll add commas accordingly. Okay. Any questions with using rounding as our first method of estimation? Trey. Okay. No, that's a good question. It's a great question. You would say then 320, right? Now you could, but I guess when I think of estimation, I think I want two things. I want it to be close to what the real answer is, and I want it to be easy to find. Okay? And I think in both examples, Trey, I think that this one here is going to be easier for me to do in my head than 3 times 32. Now, you might say, oh, 3 times 32, that's 96. That's easy. Fine. Okay? But they're not always going to be that easy. So I would just round them each to their highest place value and just be done with it. Okay? That's what I would do. That's what I'd recommend. Okay? Question? What about if it's decimals? I don't even see any decimals today, but if we did, which is fine, we can do a couple. Like if you had 4.7 times 21.9, could you use rounding for this one? 4.7, what would you round that to? 5. And then 21.9, I again would go to the highest place value and just round it to 20, and you should get somewhere in the neighborhood of 100. Okay. I'll give you a couple to try with the method of rounding. Okay. And then we'll get to the next one. Okay, so my 39 goes to what? 40, and 37 goes to 4 times 4, Samaya? 4 times 4. 16 with 1, 2 zeros makes our final answer 1,600. Next one here. I have a number in the tens, a number in the thousands. I'm just going to estimate. So CJ? 60, right? Well, let's just slow down for 1 second. 6 times 3 is the 18. And then it's just a matter of counting zeros that I multiply. 1, 2, 3, 4. 2, 3, 4. And then starting at the right, moving to the left, 180,000. Okay? I hope you got them both. Okay? Good. Compatible numbers. Compatible numbers is the next method. If two things are compatible, what does that mean? Josiah. Let's just speak generally first of all. Two things are compatible. Yes, Natasha. No, take the math out of it. Yes. Good. They get along. You wouldn't buy. You wouldn't buy a PS4 game and try to throw it in your Xbox One. Why? They're not compatible. They wouldn't work well together. However, if you wanted to think about maybe that, maybe your grandparents that have been married for 60 years, maybe great-grandparents for you. Now, they probably wouldn't have been able to last that long in their marriage if they were not compatible. We're going to use compatible numbers when we divide. See, you can't just take any two numbers and then just divide them and end up with a whole number, because not all numbers are divisible by all the other numbers. So we're going to have to do some adjusting and make sure that what we round is going to work. So let's say 477 divided by 7. Okay? Take a look at these and say, wow, we're going to be able to use compatible numbers and get an estimate for this fairly easy. When we divide and when we use division, we use compatible numbers to help us estimate with division. The first number I'm going to look at is the number I'm dividing by. And in this case, I'm dividing by a 7. How many of you are comfortable with 7s? You know your multiplication tables, your football fans, you know, touchdowns, 35 is, 5 touchdowns with extra points, of course, right? So you're good with 7s? Perfect. We're going to leave 7 the way it is. Usually if it's a single-digit number, we're good. Over here, I'm just going to focus on the first 2 digits in 477. In that case, I'm going to focus just on the 47. I'm going to ask myself a question. What number closest to 47 is divisible by 7? You start going through your 7s. 7, 14, 21. What number closest to 47 is divisible by 7? 49. So I'm going to change this to a 49 and turn this into a what? A 0. Okay. Now, 49 divided by 7 is 7. Do we have any other leftover zeros here?
Yes.
How many?
1.
Just 1. So an estimate there is going to be 70. Okay. Let's try by 6. When dividing, when using compatible numbers, what's the first number up here I'm going to focus on and decide whether I need to change it or not. Jayana? No, not yet. Which one? Always what I'm dividing by. You okay with sixes? Sure we are. We should be. Okay. Single digits, again, we can pretty much leave. I mean, you all are experts at your multiplication tables from 1 through 9 at least. Now, Jayana, I'm going to look at what? 32. What number closest to 32 is divisible by 6? Lucas. 30. Right? 30. Then this 4 turns into 0. What is 30 divided by 6? 5. Any extra zeros hanging out? Just 1. Should be 50. We are estimating, but we're using compatible numbers. We're changing things to try to make it easier for us to work with. Okay? $634 divided by 12. First number we're looking at is 12. Now, here's where it gets a little bit interesting. Depends on how well you know your 12s. Do you know your 12s? If you know your 12s, we'll keep it at 12. If you don't, what would you change the 12 to? 12?
10. Already?
Let's go 10. So I'll show you both. We'll do both. Okay. Why 10? Because if we look here and we rounded that, it would be 10. Okay. Now, looking at the 63, what number closest to 63 is divisible by 12? Nikki? 60. 60 with the 0. What is 60 divided by 12, Nikki? Georgia? 5. Any extra zeros? 50. Now, let's look at the 63 for the 10. What number closest to 63 is divisible by 10? 60 again. But in this case, how many times does 10 go into 60? With how many extra zeros? So we get two different estimates, but again, they're close enough so I could not really worry about it too much. Okay, where are we at with time? One more. 6745 divided by 33. Which one are we looking at first? Fred. 33. We're going to round the 33 to what? 30. Okay. Or if you take a step back, could you leave it at 33 knowing that you're still going to look at your first two numbers? You say, okay, what number closest to 67 is divisible by 33? 66. So you could leave it as 6,600. Then we say 33 into 66, how many times? 2 with how many zeros? And it's 200. See, very compatible were the 66 and the 33. They work very well together. You weren't expected to know your multiplication tables for your 33s, but by looking at what you had, you were able to get a very good estimate. Now, if I didn't look that far, and I just looked at the 30, I'd still look at 67. What number closest to 67 is going to be divisible by either 30 or even just 3. Let's look 30. And let's call it 60. What is 60 divided by 30? 2 with how many zeros? Okay. We still ended up with the same final estimate. We just got there in a slightly different way. Now that doesn't always happen. This one here would most likely be the closer estimate of the two. Okay? But we did some serious adjusting to this first one. All right? All the multiplication problems just on the practice side due for tomorrow. I listed all of them out. You may want to locate those and circle so that you do not omit any for tomorrow. Okay. So we're going to get to some more. I figure we should probably go through some more of the division compatible number stuff tomorrow. And we can also visit front-end estimation as well. So you should be able to handle the multiplication ones. It looks like a lot. But remember, if you do it right, they should come fairly easy to you.